We're going to talk today some more about Galileo and one of the discoveries that he made that are extremely significant in terms of modern physics. Galileo has made so many amazing discoveries, it's difficult to say which are the most important, but there's two that stand out in particular because they laid the foundations for physics that was to come much later. The first of these was a discovery that he made about the nature of motion, which laid the foundations for the work of Isaac Newton. And the second that we'll talk about in the next video is the work that he did that laid the foundations for Einstein's theory of relativity. So let's begin with what Galileo did that was so important in relation to motion that helped Newton develop his basic ideas about the laws that govern motion. Galileo laid the foundations for what later became Newton's first law of motion, and that is the law related to inertia. Inertia is the property that a body has that resists its changing its state of motion. In an absolutely astounding feat of intelligence, Galileo was able to understand that the world wasn't really the way that it looked. Now, this was something that Aristotle was unable to do. And Aristotle was unable to conceive of a situation where, for example, there was no air through which objects fell, and therefore he was led down the wrong path. Galileo, on the other hand, conducted experiments and then made the realization that what he was seeing was a more complex manifestation of something that was much simpler. But he had to make this leap to see what the simpler thing was that he was actually looking at. As I said, this was impossible for Aristotle to do. Aristotle saw things around him come to rest if they weren't pushed by an outside force, and he thought that this was the natural situation where objects needed to be pushed in order to be able to have some velocity. And so he invented the notion of violent motion that explained a cart being moved along a roadway that, unless it's got somebody pushing it, it will come to rest. Galileo, however, performed a number of experiments and then made an hypothesis on the basis of what he saw in these experiments that explained motion in many different situations. Everything from the reason that we need to wear seatbelts in a motor car or an aeroplane to stop us being injured if the car or the plane suddenly changes its direction, to the motion of the planets and the galaxy. The notion that what pushed the Earth around in its orbit was suddenly explained by what Galileo came to understand about the nature of motion. What Galileo did was he noticed that when a ball rolled down an incline, that it sped up. Nothing too dramatic about that. That it's something we are quite familiar with, that an object rolling down a hill speeds up in its state of motion. Galileo also noticed that if an object was sent rolling up a slope, it didn't continue to keep going. It slowed down on its journey up the slope and eventually came to rest. Now, the bit that is so important in what Galileo then came to understand is that if the ball slows down when it's rolling up and it speeds up when it's rolling down, what happens to it when the surface on which it's rolling isn't inclined upwards or sloping downwards? What happens when the surface on which the ball is rolling is in fact horizontal? And Galileo made the assumption that if the ball speeds up when it's rolling down and it slows down when it's going up a slope, if there is no slope at all, Galileo reasoned that the ball should not slow down at all. It should just keep on rolling. So in this idea that he had totally eliminated the effect of friction. Now, he was aware that friction was a problem, and he went on to do additional experiments after he came to this conclusion that the ball on a flat surface shouldn't stop moving at all, it should continue to move. He then conducted additional experiments. These experiments involved inclined planes, and they're the quite famous experiments that Galileo did with inclined planes. What he did was he rolled a ball down his downward sloping plane across a short surface, and then he would have another incline that he could adjust to various different angles. And what he realized was that if he released the ball from a certain height, it would roll back up to almost the same height. Now, how high it rolled did actually depend on the kind of surface that it was rolling on. If it was a very rough surface, then it didn't roll so high. But if Galileo used smoother surfaces, he could get it up to almost the same height that it had before. This is how Galileo realized about the role of friction in these experiments. As Galileo then lowered the second slope, what he saw was that the ball would still rise up to the same height, but now it was required that the ball travel further before it reached that height. As he lowered the slope even further, the same thing happened. The ball would rise to the height that it started from, but now it was required to go much further in order to get there. And then he reasoned, well, if there was no second slope, if it was just horizontal, the ball will keep going, waiting to get up to the height where it began. And since it can't get there, it will just continue to keep rolling. Galileo was right in this assumption. And it's what we now know as a particular property of a body that allows it to keep moving in the absence of outside forces. And what we know this to be, what we call this, is the inertia of a body. So Galileo came to this conclusion about what should happen if the slope is horizontal on the basis of what he saw happen when the ball rolled down a slope, and then what he saw happen as it rolled up a slope, and then making the conclusion that if it was rolling horizontally, it would just continue to keep going. He backed that up by additional experiments and realized the effect of friction that friction had on this, and so he eliminated friction from his considerations. The end result was that where Aristotle had failed to imagine a world without friction and what it would behave like if there was no friction, and therefore had no chance at ever understanding what the true nature of motion was, the genius of Galileo was that he could make this leap of imagination to what would the world look like if there was no friction. And then, not only did he have this brilliant idea, but he then was able to back it up by experimentation, by doing experiments which supported the things that he was in fact saying about the nature of motion. We now call this physical quantity that shows an object's resistance to changing its state of motion, we call it inertia. It is inertia that sends spacecrafts off into the far reaches of the solar system, even though they've got no fuel, travelling at very high velocities. It's the reason that rockets leaving the surface of the Earth can turn off their engines after a certain time, but continue to keep going. It's the reason the Earth and the planets move in their ceaseless journeys around the Sun without being propelled by any outside force. And it's also the reason that governments make laws about drivers wearing seatbelts in motorcars to keep them safe on their journeys. 20 years, around about, a little over 20 years after the death of Galileo, Isaac Newton framed Galileo's discovery into what we now know as Newton's first law of motion. Newton put it in these words, that every object continues in a state of rest or of uniform speed in a straight line unless it's acted on by an unbalanced force. So the difference between what Galileo had arrived at and what Aristotle believed about the nature of motion is that whilst Aristotle believed that in order to keep an object moving it required some sort of external force, Galileo made the realization that once a body was acted on by a force, and if that force gave the body motion, then the body would continue to keep moving unless it was acted on by another force. And this was a profound difference in our understanding of the real nature of motion. To sum up, Galileo freed physics from the crippling misunderstandings that Aristotle was responsible for, the basing of Aristotle's theories in logic and argument, which had no reality in the real world. Galileo, on the other hand, backed up his work with experimental detail and experimental verification of the sorts of things he was saying. He was really the first physicist to realize that you had to base your understanding of the real world on practical experiments where we could see and verify what the theories were that we were propounding. Galileo opened the door for modern physics by his brilliant deductions and hypotheses about the real nature of motion, and he laid the foundations for Newton to establish the laws of motion, which today are used still to put rockets into space and satellites into orbit. Very profound discoveries made by Galileo, and we'll look at one further brilliant piece of work he did to refute Aristotle and lay the foundations for the work of Albert Einstein.